Hi friends, today we shall discuss about the angle between two intersecting lines. Suppose you have two intersecting lines like this. This is your x-axis, this is y-axis. Let us assume that the slope of this line is m1 and slope of this line is m2. You see, it touches here, it forms a triangle. You know, this tangent of this theta is m2. So this is nothing but, if I take it as beta and take it as alpha, then this is nothing but 180 minus beta. I repeat, this angle, tangent of this angle, tangent of beta is your m2 and tangent of alpha is m1. So this is beta, this is alpha, so tangent of this is m2. So this angle naturally will be 180 minus of beta, that means 180 minus beta, this angle, and this is alpha. In this triangle, this is angle between these two straight lines, so theta. This is also theta, so theta plus alpha plus 180 minus beta is equal to 180. Sum of all the angles of a triangle is equal to 180 degree. So theta, this one, plus alpha, this one, plus this angle 180 minus beta is 180. 180 goes with this, so theta is equal to beta minus alpha. Now we have come to a result that this angle is nothing but beta minus of alpha, this angle. So if I take tangent on both sides, it becomes tangent of theta is equal to tangent of beta minus alpha. As we know, tangent of beta minus alpha is nothing but tangent beta minus tangent alpha whole divided by 1 plus tangent beta multiplied by tangent alpha, and tangent beta is nothing but m2. So I can write it as like this: m2 minus m1 whole divided by 1 plus m1 into m2. So tangent of theta, so angle between two straight lines, intersecting lines, is equal to tangent inverse of m2 minus m1 divided by 1 plus m1 into m2. So this is the formula I have derived to know the angle between two intersecting lines, that is this theta. This theta and this theta are same opposite angles. This is equal to this minus this, I have derived. So taking tangent, it becomes this one. So this is a formula. If we know the slope of one line and the slope of another line, we can substitute the values in this formula to get the angle between two intersecting lines. Now we'll take some examples. Suppose I have linear equation like this. One linear equation is L1, that is given as y equal to 2x plus 3, and line 2, this is given as 2y is equal to minus 3x plus 8. Now I am asked to know, to calculate the angle of intersection. Now in L1, what is my slope? Slope is 2, and in second line the slope is, if I take it 2 on this side, so it becomes 2 here, 2 here. So this is slope minus 3 by 2. Now I have a graph like this. This is x-axis, this is y-axis. One is m1 is 2. That means the slope is 2. That means as x increases, y also increases. So can it be like this? X increases, y increases. No, it has to be like this. So one line is like this. This is your line which has slope equal to 2. So I call it as m1. This is one line. Then another line, 2y is equal to minus 3x plus 8, or y equal to minus 3 by 2x plus 4. Now here, if x increases, y decreases. So that means it has to go like this. So I am asked to calculate the theta. So this line has slope of minus 3 by 2. Now I substitute the values here. I find tangent of theta is equal to m2 is minus 3 by 2 minus m1, that is your 2, divided by 1 plus minus 3 by 2 multiplied by 2. This 2 goes with this 2, so it becomes minus 7 upon 2 whole divided by 1 minus 3, that is minus 2. So this becomes 7 by 4. So tangent theta is 7 by 4. So theta is nothing but tangent inverse of 7 by 4. And the value of this is 60.26 degree approximately. So what I want to say is, you substitute the values. First you calculate m1 and m2, substitute the values in this formula, calculate tangent of theta, and theta is tangent inverse of the value which you received, that is 7 by 4. So this way you can calculate the angle of two intersecting straight lines. So I take another example, number 2. Suppose I am given L1 such that y equal to 2. This is one equation. And L2 is given as 3y equal to minus x into root 3. These are two lines given. Now what is my, before I calculate the slope, I would like to draw. This is x-axis, this is y-axis. Y equal to 2. That means there's something, a line like this which is parallel to x-axis. This is the equation of this straight line, y equal to 2. Now if I draw this line, that is y equal to minus root 3 upon 3 into x, or minus 1 by root 3 into x. Slope is minus 1 by 3. If x increases, y decreases. That means something like this. So x and y, if x is 0, y is 0, that means this line shall pass from origin 0, 0. So I am going to get a line like this. This is line which represents 3y equal to minus x into root 3. This is line 1, this is line 2. I am asked to find out this angle between this line. I just make it darker, and angle between this line, right? Now I'll substitute the values, but before I proceed, I want to know which one is line 1 and which one is line 2. See, if I start from x-axis, from here I come across this line first. So this is my line 1. So that means M1 is equal to, here in this equation, m1 is equal to 0 and m2, this line, and this is equal to minus 1 by root 3. Now I will substitute these values in the formula. Tangent of theta m2 minus 1 by root 3 minus 0 whole divided by 1 plus something into 0, so 0, it becomes 0. So I am left with minus 1 by root 3. Now tangent of theta is minus of 1 by root 3. Can I write it like this? This is equal to, as we know, 1 upon root 3 is nothing but tangent of 60 degree. No, 30 degree. Tangent of 30 degree. If you want, I can write it here. 0, 1, 2, 3, 4. This is 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. 0, 1, 2, 3, 4. So take under root of all. 1 upon root 3 is nothing but 30 degree. So this table we must memorize. Anyway, so I substitute the value of 1 upon root 3 as tangent of 30 degree. Minus sign is obviously, it is there, so it will be carried forward. So I have reached at a point which says tangent theta is equal to minus of tangent 30. I want to know theta. Minus of tangent of anything is nothing but tangent of 180 minus of theta. Then it becomes positive, because tangent of 180 minus theta is equal to minus of tangent theta, because this falls in the second quadrant, and in second quadrant, this is quadrant 1, this is 2, this is quadrant 3, this is quadrant 4. So 180 minus theta, it falls here. Here tangent is negative, here all are positive, tangent is positive. Here tangent is positive, here tangent is negative. So in second quadrant it is negative. So that means tangent of 180 minus theta, 180 minus theta is negative of tangent theta, right? So here tangent theta is equal to tangent of 180 minus 30, because this is nothing but minus of tangent 30, right? So therefore I find theta is equal to 150 degree. This is the answer. So angle between these two straight lines is 150 degree. So that means this is 30 degree, this is 150 degree. So the obtuse angle is the angle between these two straight lines. So what I need to remember, whether the angle between two straight lines is an acute angle or an obtuse angle. See, this is also angle between these two lines, and this is also the angle between these two lines. So it hardly makes any difference. But how to present the results, that is very important, because we have certain conventions, and the convention says that you don't have to write the acute angle. Here it was 30 degree. You don't have to write the obtuse angle. Just follow the rule. The rule says whatever value you get, you have to present it. Through this formula, there is that formula on the next page. Yeah. Through this formula, whatever value you get about the angle between two straight lines, you have to present your data. You have to give your result in the shape of the value which you have received. So the only convention is that you have to write the answer is theta is 150 degree. You would not say that the angle between these two straight lines is 30 degree. Though this is correct, but we follow certain conventions. We follow certain conventions or assumptions. Everybody has to follow certain rules. And the rule says you have to present this data. So here in this case, theta is 150 degree. So this was regarding the second example. Now we take another example. Example number 3. We have L1 such that y equal to x into root 3. This is your line 1, and L2 is x equal to 2. Now if you see closely, x equal to 2, that means a line something like this which is parallel to y-axis. If you see closely this equation, I mean the linear equation of this straight line, what do you see? What do you infer from this line? You see, the value of x remains constant too, whereas value of y may increase or decrease. So that means theta in this, there is no triangle rather, but here the theta is, because y is going towards infinity, so theta is 90 degree, right? And in this your m is root 3, or it is 60 degree, right? So before that I will draw this straight line, y and x. If I put x equal to 0, y is also equal to 0. So that means it passes through this. Whether it will pass it like this or it will pass it like this. As y increases, x also increases. So that means it will pass this origin like this. Because if x is, let us say 5, y is 5, if I increase x, y also increases. So that means x increases, y also increases. So the positive relationship, it will have shape like this. So I will make the two straight lines darker so that we better understand about the angle between these two straight lines. Now basically these are the two straight lines. Which one is M1 and which one is M2? Because here M1 or maybe M2 is not defined. Tangent theta, tangent 90 is infinity. Now here what I will do, the angle between these two lines. So this is the angle. If I take up this right angle triangle, this is my M of this line, right? This is under root 3. I am interested in knowing the angle between these two. So that means this angle, and this is 90 degree. So I am interested in knowing this angle. If this angle is root 3, that means this angle is nothing but 60 degree. So angle between this third angle, this is right angle triangle, 90, 60, so this is 30. So that means angle between these two lines is 30. So therefore theta is 30 degree. So I have to take an exception, and that exception is if I have a line, vertical line, that is parallel to my y-axis. So if I have to find out, I will find out this angle subtracted from 90 degree, because this is 90 degree, subtracted from 90 degree. I will, from the slope of this line, I can very well find out the angle of inclination. Once I have found this angle, I can subtract it from 90 degree, because this is already 90 degree. So 90 minus of this angle is nothing but the angle between these two intersecting lines, because here the line is proceeding from minus infinity to infinity. Here tangent theta is infinity or theta is 90 degree. So when it is 90 degree, you just subtract the angle of other line from the other line's slope can fetch you the value of theta, because slope here it is root 3, and if tangent of alpha is root 3, that means alpha is tangent of minus tangent inverse of under root 3, and tangent inverse of under root 3 is nothing but 60 degree. So you have calculated this value that is the slope of this line 60 degree, and you are interested in knowing the angle between these two intersecting lines. This angle, this is 90 minus 60, that is 30. If this is 30, this is 30. So this angle between two intersecting lines, when one line is vertical or parallel to y-axis, then from the slope of the other line subtract that value from 90 degree and you arrive at the result, and in this case angle is 30 degree, because slope is, this angle is 60 degree, so 90 minus 60 is 30. So answer is angle between these two linear equations or straight lines is 30 degree. This is the answer. So I sum up. To find out the angle between two intersecting lines, you take the help of this formula which says angle between two straight lines, tangent of that angle is equal to slope of one line minus slope of another whole divided by 1 plus m1 into m2. After finding out tangent theta, you can find out the value of theta by doing inverse of that value. Now this value, if you may receive as obtuse angle, or you may receive it as acute angle. You have to present as such without changing. And if there is a vertical line, one line is vertical line where theta is 90 degree or slope is infinity, in that case you find the slope of the other line, subtract that angle from 90 degree, you get the value of the angle between the two intersecting lines. So this was something about intersecting lines. If you are interested, you may contact me on my WhatsApp number for further discussion. Thank you.